For any homework-related queries, call us at +1 678 648 4277. You can mail us at info@excelhomeworkhelp.com or reach us at www.excelhomeworkhelp.com. Problem 1. Consider a random variable x with the triangular PDF shown below. Note that this distribution has one unknown parameter a. Its mean and variance are excelhomeworkhelp.com. Extra credit. Work in between is required. Suppose that you obtain a random sample of 8 x values, x1, x2, x8. Perform the following steps. A. Devise an unbiased estimator A for the parameter A that depends only on the sample. B. Derive the mean and variance of this estimator. Is the estimator consistent? Y. C. Suppose that the 8 values of your random sample are 0.15, 0.32, 0.65, 0.080, 0.280, 0.280, 0.050, 0.12. excelhomeworkhelp.com. Derive a large sample two-sided 95% confidence interval for the parameter A. Note that it is related to but not equal to the population mean E, x. See expression for E, x, above. Hint: the two-sided 95% values for a unit normal distribution are -1.96 and +1.96. D. Test the hypothesis H0. A equals 1 by deriving a p-value from the sample values given above and the unit normal CDF attached to the quiz. The CDF is plotted on normal probability paper. Assume that the sample is large. Hint: please note that H0, A equals 1 is not the same as H0, E, x equals 1 for this problem, since E, x is not equal to A. Solution. The estimator is consistent because its variance goes to 0 as the number of values goes to infinity. excelhomeworkhelp.com. C. Sample mean equals 0.241. -1.96, 0.723a, /0.192 less than 1.96, 95% confidence interval 0.35 a less than 1.1 d. H0. A 0 equals 1 z sad face 0.723 to 1, /0.192 equals -1.44 reading off the graph. P/2 is almost equal to 0.075 p equals 0.15. excelhomeworkhelp.com. Problem 2. Provide specific one-sentence answers to the following questions. A. Define a random sample. B. What are the implications of making a large sample assumption when deriving confidence intervals or testing a hypothesis? C. How is the variance of a sample mean estimate of the population mean related to the sample size? D. How does a two-sided confidence interval for the population mean change as the sample size changes? E. How does the two-sided rejection region for a hypothesis test of the population mean change as the test significance level changes? Solution. A. A random sample is one in which the she's are independent, and each she has the same probability distribution. B. A large sample assumption means that the sample is large enough to assume that the estimate of interest is normally distributed. C. The variance of a sample mean estimate of the population mean is inversely related to the sample size. Therefore, the variance decreases as n increases. Note: the variance of the sample mean estimate is not the same as the variance of the data. excelhomeworkhelp.com. D. As the sample size increases, the confidence interval width decreases. This makes sense, since the more data points you have, the more confident you are in your estimate, so you can make your interval smaller, i.e., you are really sure the true value is not far from your estimated value. E. As the significance level increases, the rejection region also increases. Problem 3. Write a brief MATLAB program to display the histogram and estimate the variance of the sample 1-4 mean of a random sample, x1, x2, x2, x4, of size n equals 4. The desired histogram and variance should be computed from a population of 1,000 replicates. Assume that x is exponentially distributed with parameter a equals e, x equals 1. Do you think the histogram will closely resemble a normal distribution? Why? Please write your code neatly and precisely so we can enter it into MATLAB to see if it works. Solution. MATLAB code, nrep equals 1000. excelhomeworkhelp.com. A equals 1, n equals 4, zamples equals expend, a, n, nrep, sampmeans equals mean, zamples, hist, sampmeans, var, sampmeans. The histogram will not be normal since there are a small number of samples being averaged, 4, and the original distribution is exponential. It is, however, more normal than the exponential distribution because of the central limit theorem, which states that if we add a large number of random variables together, the sum, or mean, will be normal. But our n is only 4, so we can't expect it to be completely normal. Note that the number of nreps does not really matter, except to visualize the distribution and get the variance. It is the actual mean of the 4 numbers that may or may not be normal, so the 4 is what counts. Here's the histogram from the above program. excelhomeworkhelp.com. excelhomeworkhelp.com